It is a great pleasure to present this paper which describes the application of process mining to end-to-end order processing. We believe that process mining is very, very important for manufacturing. Therefore, I'm very pleased to present this paper. I would also like to thank my co-authors, Günther Schuh, Andreas Gutzlaff, and Seth Smits, for contributing to this paper. I will not only describe the paper, but I will also explain for the people that are new to the topic of process mining what it is, how it works, what kind of tools are available, etc. So the scope of what I will talk about is a bit broader than the paper itself. So let's start with a short motivation. So organizations want and need to improve their operational processes, for example, production, manufacturing. They can use techniques like business process improvement, business process re-engineering, but all of these things are only possible if there is a good understanding of the problems in the actual current processes. And process mining is an incredibly important technology to do that. What is the problem if we look at end-to-end order processing? The problem is that we can focus on the manufacturing phase itself, but if we look at the total order time, it is not only composed of the actual manufacturing, but there are many other processes involved, as you can see here. So if we would like to improve end-to-end order processing, we need to look at all of these different processes, but the data related to all of these different processes are typically stored in different tables and different systems. So in this paper, we make the case that it is vital to kind of assemble all of this data and to create holistic process models able to capture the end-to-end process. What the table below shows here is that when we ask people that are involved in this process what the activities are, that they only name a fraction of the actual activities. That shows that people have a limited understanding of the complexity of such end-to-end processes, and that makes data-driven techniques like process mining very important. Okay, to explain process mining, I would like to start by an overview, a very general overview. We have information systems. These information systems generate all kinds of event data. When I talk about an information system, I mean systems like SAP, Microsoft Dynamics, Oracle, but also all kinds of homegrown systems used in production, manufacturing, assembly lines, etc. When we have such event data, we can use process mining tools to explore these data, to already identify certain patterns, to select the data, to clean the data. Often there are data quality problems. And once we have done that, we have scoped and cleaned the data, we can automatically generate process models, as you can see here. So there are lots of discovery techniques available. This is pretty standard today. Such process models can be shown to stakeholders. They will immediately see all kinds of surprising things. You can interact with these models, modify these models. So you can pick the interaction between reality and reality as people expect it to be there. What we can also do, and this is incredibly powerful, we can take such models and we can replay reality on top of these models. And this is used to reveal conformance and performance problems. So we can see, for example, where are the most serious bottlenecks? Where are there deviations or where are there outlier behaviors that explain certain problems? So for example, we can look at an activity that we expect to be there, but it is skipped or it is done multiple times. Then this can be exposed by replaying the event log on top of the process models. These process models can have been made by hand, they can be discovered automatically, or you can choose to use a kind of hybrid approach. Such performance and conformance diagnostics can be shown to end users. People can drill down, and it is always possible, if you see a certain problem, to go back to the original event data and understand what is causing the problem. If you have lots of data and a relatively stable process, such models also have a predictive value. So you can use the automatically generated models to make predictions and also to suggest improvements. And of course, the goal of all of this is to actually improve the processes by changing them. Machine learning, in its, let's say, mainstream sense, only plays a role in this last step. If you look at process discovery and you look at conformance checking, the process mining techniques are very different from mainstream machine learning techniques. However, if you have applied these first process mining steps, then you can apply mainstream machine learning techniques like neural networks to, for example, diagnose a particular problem. Okay, this is all very high level. Let's try to make it more concrete. So here we are looking at example event data. Every row in this table corresponds to a single event. There are 71,000 rows corresponding to the different events, but this is referring to the so-called order to cash process, but I simplified it a lot. I removed lots of activities to only look at 7 unique activities. So in this data set we have 12,000 orders, 71,000 events, and only 7 unique activities. If we look at event data, then a minimal requirement for each event is that we have a case identifier, an activity name, and a timestamp. Timestamp is obvious. Activity name, I think, is also clear. Things like payment, place order, or a particular production step. The case ID is sometimes a bit complicated. In this example, it's very simple because every event refers to an order, and we take the order identifier as our case notion. In other applications, it may not be so straightforward. If we have such data, we can look for certain patterns. So here I picked 3 orders. A blue one, a red one, and a green one. And if we look at the blue order 6350, then we see this sequence of activities. And so we simply sort the events based on timestamp, and then we look what are the events corresponding to a particular case. In this case, the blue order. We can do the same for the red order. And for the red order, we only see 3 events: place order, send invoice, and cancel order. And we have the green order, and the idea is in essence the same. It looks very much like the original blue order, only the steps prepare a delivery, make delivery and confirm payment have been swapped. So this is what we can extract from such data. And if we look at the entire log, we see that the blue trace, the blue sequence of activities, was actually not just for this order that I just showed, but of the over 12,000 orders, 8,000 orders followed this particular pattern. 1,600 followed the red pattern, almost 3,000 orders followed the green pattern. But if we look at all the data, we also see, let's say, more rare, exceptional behaviors. So for example, in total, we see 37 cases where people pay before they get the invoice. And again, we see the variation of, at the end, we can do make delivery, confirm payment, or we do confirm payment or make delivery, because these activities are concurrent and no particular order is specified. If we take such data, we can explore them, but of course the goal of process mining is not to just manually explore them, but to automatically generate models for predictions for all types of analysis, bottleneck analysis, deviations, etc. So what is key to understand is that given such event data, we can automatically construct process models, and these process models show us what is really going on. I'm stressing here that we can do this without any modeling. We can also model, but we can also do without, and then we see the processes as they are really being executed. So what is the purpose? We can find out what is really happening, and I'm showing here static slides, so that's not very convincing. But if we would look in the tool, then each of the yellow dots here would correspond to an order, and we could trace how particular orders are flowing through the process. So we can show people what is really going on. We can also show people where the bottlenecks are. So using process mining, you automatically identify what are the activities that have the highest waiting or service time. And so here you can see some examples. The more red the activity is, the longer the time is spent in front of this activity. If we have a normative model, then we can also automatically check compliance using conformance checking technique. So we can, for example, look at what is the happy path, what is the desired path, what is the path that is taken in 80% of the cases, and we can look for deviations from this path. And then we can drill down what do these cases that have this particular deviation, what do they have in common. And there we can again apply machine learning techniques after doing these first steps. So that's the basic idea of process mining. We can immediately see, without any modeling, where things are problematic, and we can automatically generate ideas on how to improve them. Of course, I just showed you a very simplistic example where I filtered it very much. I only had 7 activities. Reality is a bit more complicated. Earlier I showed the order to cash process. Here I'm showing you some real-life data from SAP from the purchase to pay process. So this is when we look at the happy path. This is the process model as we already, let's say, lower our threshold, and we are willing to see, let's say, more low-frequent behavior. If we look at all the behavior, and again, this is a super simplified log, we see that there are many connections. So real-life processes are much more complicated than people think. If we look, for example, at the order-to-cash process, and we look at an organization like Siemens, we will find 900,000 different ways of executing the order-to-cash process. And this is illustrating, let's say, the value of process mining, that you can find all these, let's say, these unexpected behaviors that are costing time and money. You can identify the most severe problems and you can address them. So that's basically what process mining is all about. It is applied in many different disciplines. We started doing process mining research, let's say, over 20 years ago. In the 90s, I was the first one to start working in this area. For a very long time, my research group was the only research group in the world actually doing this type of research. The tool that we developed, let's say, right from the start, was the tool called PROM. It's an open source process mining system, also used to generate the models that I showed before. If you look at PROM, it served as an example for lots of commercial tools. So today there are over 35 commercial process mining tools, new tools popping up every day. Process mining capabilities are also being integrated in lots of other systems, for example, business process management systems or robotic process automation systems. I think a nice example, if we look at the names on this slide, to elaborate a bit on, is the system Celonis. So Celonis is a company that started in 2011. 3 students of the Technical University in Munich started using, let's say, the PROM software and got the ideas to build, let's say, their own process mining system. Today, Celonis is one of the few unicorns in Germany, so startup companies that are highly valued, and they are an example, but there are many more examples of successful companies applying these ideas that we developed earlier in our research. So let's go back to the paper. So process mining is an established technology. It is used in many domains, but it is not that widely used yet in the area of production. And we think that there are lots of opportunities. One of the, let's say, key challenges that we have in this domain is to extract data from different sources and to merge them in such a way that we can create more holistic end-to-end process models. So in the paper we identify a methodology consisting of 3 steps. The first step is to actually get the data from the different sources, clean the data, etc. Then we merge and prepare the data. And what is very difficult in this phase is that the data may use different identifiers, and we need to consolidate them. And then we apply, let's say, process discovery techniques. But what we typically need to do in order to do the last step is to pick a particular case idea. So that's the basic idea. And in the paper we describe a particular application of this 3-step methodology. So we are collecting data from different systems, and we are creating a so-called object-centric event log. And an object-centric event log, there every event is not referring just to a single case ID. No, it is describing all the different objects involved. This is very important in manufacturing applications, because it is not so simple that we have a single case ID that is obvious. From these object-centric event logs, we can generate multiple views, and for each view we create a so-called XCS log. And so XCS is the IEEE standard for recording event data, and this type of event data can be loaded in all kinds of process mining tools, including the PROM system that I mentioned before. So we applied this, and then we had, let's say, close to 300 cases, over 50,000 events, and lots of different activities, as you can see here, almost 900. So using this data, we went through the different steps of our methodology, and what we first did is that we addressed some data quality problems. We clustered different activities, and what you can see here is, let's say, the event log before and the event log after. Note that in the cleaned event log we still have 850 different activities. So that's very difficult to visualize, but using our process mining techniques we can use, let's say, automatically frequency-based filtering. So if we apply the inductive visual miner with the settings that are indicated on the slide, we get a relatively, let's say, simple process. But it's only showing a fraction of the actual activities. If we look at this process, what we see if we analyze it further, we see that there are many different activities involved, and that, let's say, assembly is not the main bottleneck if we look at the end-to-end process. So for the end-to-end process, we should not consider just the assembly step itself, but we should also consider the surrounding processes. So that's an example of the application of, let's say, the process mining methodology that I just described. Okay, let's come to a conclusion. So process mining is a new technology that, in our view, is incredibly important for production engineering. Its application in this domain is relatively new, but we think that with the increasing digitalization of production processes, much more event data will become available, and this is a technology that is ready to be applied. And at the same time, there are many interesting scientific challenges that we can still work on. Of course, this smells a bit like machine learning and AI, digital twins, and all kinds of other things. I think one important difference with, let's say, many people that talk about AI and machine learning is that this is very concrete, and this is something that you can already apply today. Earlier, I also explained the connection to machine learning and artificial intelligence. It's crucial to see that in the first two steps of process mining, doing process discovery and then replaying the event logs on top of the discovered process models, we are not using mainstream machine learning and AI techniques. After this step, we can apply this. So you could argue that process mining is enabling the application of machine learning and AI in these domains. You could also argue that process mining is a technology to turn, let's say, notions like the digital twin into reality. In this paper, we made the case that it's very important to apply process mining not to parts of the process, but to apply it to the end-to-end order handling process, including sales, procurement, and the actual assembly steps. This is not trivial, and one of the key problems is to, let's say, merge the different data sources and to deal with the problem that there is not such a thing as a single case ID. So there's ongoing research in the area of object-centric process mining, where we develop process mining techniques tailored towards this particular problem. This paper provided a three-step methodology, as also visualized here, and we showed a small case study applying this methodology in a real-life setting. If you are interested in this, then of course you can read the paper, which talks about this methodology and let's say the case study that I just mentioned. It may also be that this triggered your interest in process mining, let's say in a general sense. Then you could read the process mining book. You can also take the Coursera course. The Coursera course by now has been taken by over 125,000 participants. What I also mentioned before is that you can use open source software like the prompt tool set, but there are also many commercial tools that you can use. And the threshold to get started with process mining is really low today, provided that you have good data management and you actually have the event data available. I would like to thank you for your attention and hope you will apply what you have seen in your own context. Thank you very much.